Hello, my biochemist friends. So today we're going to be talking about water, acids, and bases, and this is the very last section of the chapter 2. We probably won't get to this information for a little bit, but I want to make sure that we cover it soon because it will help when we are observing different things in the lab. And I do apologize, my throat is kind of scratchy, so I kind of sound dumb. All right, so I obviously forgot to include an objective side again, but the things that you should probably be able to do at the end of this video is I want you to be able to identify water's structure and properties, which we'll talk about right now, be able to define acids, bases, and pH, and know what acids and bases look like on the pH scale, and maybe some examples of those two things. And then I also want you to be able to explain why water is so essential to life. And I'm going to explain this. This chapter really helps tie in why we're learning about biochemistry and why these chemical components are so important in sustaining life on Earth, and how we really do have like a perfect setup for living organisms. All right, so like I said, the first thing we're going to talk about is water and the structures and properties of water and why water is actually so perfect. So some properties of water that you probably already know is you probably know that water is tasteless and odorless. Some may debate that because I feel like I've bought water that does not taste as good as other water, but who am I? You probably already know that water is transparent, which is a really good thing because it allows light to pass through it, and obviously living organisms need light for energy. So this is a really good thing. Another thing you probably know is that water is made of 2 hydrogen atoms and 1 oxygen atom. And so that was my first point here. The biggest factor of water is that the hydrogen atoms are bonded to your oxygen atom by hydrogen bonds. And I don't expect you to know any details about them. What I do expect you to know, though, is that those bonds are strong enough to keep the water molecules together. Now, these hydrogen bonds are not very strong, but they are strong enough to keep water together. And so that's why when you see it dripping out of a faucet, it's all in one drop and not just kind of broken apart. And so hydrogen bonds are strong enough to do the job of water. Another factor I do want you to know is that water is slightly polar, meaning that it has some kind of charge to it. I'm not going to go into details on those kinds of charges, but I do want you to know that it is slightly polar. Properties of water. So like I already mentioned, water molecules, they stick together thanks to those hydrogen bonds. Water has a fairly high boiling point. It boils at about 100 degrees Celsius. So among other compounds, that's a pretty high boiling point. And it takes so much energy to boil water. You probably learned that in Science 1. If you didn't, we are going to cover it a little bit, but not super detailed. Water also expands when it freezes. So if you were to put water in a bottle and then put it in the freezer, take it out, the bottle looks fatter. And then if that water melts, again, the bottle looks fatter. It's because that water expands. And this is a good thing. This allows for fish to live under ice that's under the lake, or above a lake. Fish can still live under there because of that expansion. So that's a good property. And water has low density. So those are properties and the chemical structure of water. That is the main basics that I want you to know. I really don't expect you to go into any more detail about water. Okay, so let's talk about acidity and pH. So you probably heard of the word acids. But maybe you still don't know how to use that in a describing sentence. So the first thing, let's talk about water. Water is the main ingredient in all solutions. And a solution is a mixture of 2 or more substances that has the same composition throughout. So it's a type of mixture. And so some solutions are acids and some are bases. The best way to understand acids and bases is when we talk about hydronium ions. It's basically just when water is broken down, hydronium ion is released, so it's just a form of hydrogen that's released, and that builds up. The more hydronium ions you have, the more acidic something is. Another important fact that I just mentioned about hydronium ions, the greater the hydronium ion value, the more acidic a solution is. So I want to talk about a pH scale. So a pH scale is a scale that tells us whether something is acidic, neutral, or basic. So it's a scale from 0 to 14, 7 being neutral. Water is our most neutral solution, if you will. So most neutral mixture. It has a pH scale of 7. So anything above or below that indicates that you're going away from neutrality. Anything below 7 is known as an acidic solution. So that means, I'm going to write this down for you, 0 through 6 are acids are going towards acidity. So you have a greater concentration of hydronium ions, means you have a lower pH value. So high hydrogen ions, low pH value. And so acidity and bases are measured on the pH scale. And like I mentioned, pure water has a pH of 7 neutral. I don't really expect you to go into details on the hydronium ions. It's not something that we are going to focus on, but I would like you to know just the background information so you understand why they are given that value. So let's go into a little more detail on acids and bases. So like I had mentioned before, a solution with a pH lower than 7 is called an acid. These are more acidic, the lower its pH value is. More acidic, the lower its pH value. Good examples are like vinegar, hydrochloric acid. So as your pH value gets lower, the more acidic you get, the more dangerous and deadly these things get. Now, don't think that we don't ever use acids. We use acids in our body all the time. For example, there are acids in our in our stomachs that are super essential for enzymes to function. And we learned about enzymes in the last video. Enzymes in your stomach, known as pepsin, can only perform with the environment given off by the stomach acid that we have. So it sounds kind of weird, but super essential. And then on the opposite end of the scale, you have anything above 7, and those are known as bases. So a solution with a pH higher than 7 is a base. More basic, the higher the pH value is, and these examples would be baking soda and bleach. These things are things that are lower in concentration of hydronium ions. So the hydronium ion concentration is lower, but your pH value is higher. And again, on the opposite end of that scale, these things are still very dangerous. As you get to 14, you're increasing on causing damage to yourself or to other structures. So for example, lye can burn your skin, bleach can also sting your skin, and it also can remove color from your clothing. So where this comes into play for living organisms, right? Because this is biology and we relate everything to living organisms. Our acids and bases are super important in ensuring that enzymes can perform their job. They have to be at a certain level of acidity and a certain level of basicness, if you will. So you can go ahead and give them a pumpkin spice latte if you want, but acids seriously can only function at certain environments, and those enzymes can only function at those certain acid levels. So they're super essential. Like I mentioned already, pepsin inside of our stomach only functions with the presence of stomach acid. Your cells secrete acids and bases to help house enzymes. And like I mentioned already, pepsin. And this isn't the only, I didn't mean to draw that. But anyway, this isn't the only acid and base found in our body, but this is one of those that it's easy to picture. And so finally, water is essential for biochemical reactions. When we start talking about photosynthesis and cellular respiration, you're going to see that you'll either have water as a product or water as a reactant. Super essential in ensuring that these biochemical reactions occur. So it's involved in many other biochemical reactions. So basically all of life processes depend on water. Really, that's how we round it all together. Water is super essential. It really helps make every single biochemical reaction go. That's including energy. It's also including bases and acids, also includes enzymes. So everything ties into one another. And full disclosure, I don't feel like this was my best video. I feel like maybe things were really confusing in how I explained it all. So I will be going into a lot of detail in class with this video. If you have any questions, please feel free to ask me on Edpuzzle.